more device is called a network, or we can say interconnection of two or more device. Okay, communication between two or more interconnected device is called a networking. Internetwork is a connection of two or more networks. You have a two networks or a more three networks, four networks. If you connect 3-4 networks or two or more networks together, it is called a internetwork. Internetworking means it is a communication between these networks. Okay, and there is a different type of networks are there. So generally you are telling in a geographical range. So like a LAN, CAN, MAN, WAN. Local area network is simply a room or a floor or maybe a building, entire building. That is a entire building is a maximum size of a single local area network. Campus area network is like a university campus or a college campus or maybe some organizations, big organization campuses are there, like a TCS campus. Okay, multiple buildings are there, so each building is, for example, is a LAN. Okay, so all these LANs comes together and become a very large network. So that is a campus area network. MAN, metropolitan area network. So what is a metropolitan area network? Within the city limit. So you have a network, so different departments in the a city, so they are communicating each other. You establish a connection between those departments within the city. Is a metropolitan area network. Wide area network is like our internet, so anywhere from globally you can able to communicate from anywhere to anywhere. So that is a wide area network. So entire globe is a wide area network. Other than that one, so there is some area networks are there. Example, personal area network, like you have a mobile phone, you have a earphones, headphones, Bluetooth headphones kind of stuff, right? So personal thing, your smart watches. Okay, so these are all a personal area network for a person. Home, entire home automation related, smart TVs, smart printers, Wi-Fi printers, your laptops, mobile phones, LEDs. These are all comes under home area network. So here, okay. There is another area network called a storage area network, which is not comes under this area network, but still there is some books or some internet searches. It shows that one. So don't get it out. It is belongs to storage related solutions. Okay. So this is a explanation about it. I didn't written anything. Just important is first we have to understand, guys, how to tell an answer at the time of interview. That is very important. So people will hear the things in a classroom, but we will forget, right? So we will forget. Like I heard some class about something like maybe a Python or maybe AWS or maybe Azure. So I heard, then I forget easily. So hearing is easy to forget. So what to do? Better to prepare a notes, right? So notes, PPTs, PDFs. So then we will read it. Then maybe there is a 1% of chance of remembering, 1%. So 0% to 1% remember. So you can little remembering things, right? So what to remember better and as well as how to answer the time of interview. It's only based on a practice, guys. Just read it once, practice twice at least. So for example, what are the types of network? So don't put anything, just you read once, or write once, read once or write once. That is completely up to you. How much notes you prepare is 1% only, but how much you are able to speak at the time of interview, that is very, very important. Of course, preparation of notes is also very important. Okay. So for example, here is a question, types of networks: LAN, CAN, MAN and WAN. 4 only. Okay. So local area network, campus area network, metropolitan area network, wide area network. Again, local area network, LAN is a size is up to a small up to from a small room or a single floor or an entire building. Campus area network, multiple buildings in a single campus. So that's the range is single campus range. Metropolitan area range is up to city, the connection of devices and networks within the city only. So like we are connecting different departments. Next, wide area network. So what is a wide area network? So it's a global network. So geographically, so different continents, different countries, different states, like geographically separated places we can able to communicate, right? So it's a global network. Okay. What are the medias are there? What are the cables type are there? Coaxial cable we use it. UTP, STP cables we use. Fiber optical cables we use. Generally we are using UTP, STP cables. Unshielded twisted pair cable, shielded twisted pair cable. Fiber optical cables. Fiber optical cables for a very long distance and high speed data transmission purpose only. Okay, so UTP, STP generally we are using for our LAN communication purpose. Coaxial cables generally we are not using for a network communication purpose. That too currently we are not using. Simple, right? Any other things we are like a what is NIC? So once you read it, just read it or go through the video or notes. Okay, just read it. So see, look at. So what is a NIC? Network interface card. Also called as a LAN card, also called as a Ethernet card, and there is a MAC address. It is a 48-bit address, also called as a physical address or a hardware address. It represented in 12 hexadecimal. It is look like this one. Okay, so how to check the MAC address? Get MAC. Have to check the MAC address. Get MAC or a IP config space /all. Okay, so Ethernet. Okay, so this NIC generally for a computers we have a connection is there, no wire connection, so that we call it as a Ethernets. Okay, NIC also called as Ethernet cards. So earlier we have a Ethernet, later the fast Ethernets came, then gigabit Ethernet. Ethernet is a 100 MB, 10 Mbps. Fast Ethernet means 100 Mbps. Gigabit Ethernet is 1000 Mbps. We cannot change the MAC address of a system because it's given by manufacturer of NIC. Okay, that's it. Again, now completed, then practice. Try to tell in the question. So, can you able to tell about NIC? Or can you, what is MAC address? So, out of all these things, I'm asking you only one question. What is MAC address? So, MAC address, media access control. MAC address, media access control. MAC address is also called as a physical address. Manufacturer of NIC give that MAC address to our NIC. Okay, the NIC having a MAC address. Manufacturer of NIC is given that are enhanced or integrated. Any word you can use it. Okay, in the NIC device. Okay, to check the MAC address, we can use the command called get MAC or a IP config space /all, and also we can check with the GUI mode. Go to ncpa.cpl, go to run and then type ncpa.cpl. It opens network connections. Right click on your adapter status, then click on details. You'll find physical address, that is our MAC address, and also we can see IP address, subnet mask, default gateway, DHCP server address, DNS address also. This is how to tell an answer. So only one question, but you are elaboratingly telling means you know better, or stick to the question only. So what is a MAC address? Media access control. It is a hardware address given by manufacturer of NIC, also called as physical address. 12 hexadecimal. The MAC address is 12 hexadecimal. In a binary, it is 48-bit binary 48-bit number. Okay, that is enough. Like you can reduce it like a 2-3 lines, or maybe 4-5 lines, maybe 5-6 lines. It depends upon how much you can able to tell, guys. Always, which is the best one is what you know better, what you can able to present better, what you can able to work better. It is always right. So there is a lot of applications are there. For example, if you see, here is a Eclipse application is there, and there is a Apache NetBeans is there. Which is the best one? Both are Java IDEs only. Which is the better one? For example, this is a PyCharm. PyCharm is a Python IDE. And I have a VS Code. VS Code is not any IDEs. It is anything you can do in VS Code. Okay. Okay. So anything like you want to Java, or you want a Python, you want a HTML, you want some other programming. So you can do it in a VS Code. So which is the better one? Atom is there. So which you practice better? Which you know, you well known for you. You practice which one is better. You feel which is good. That is a better always. You buy a bike, or you buy some model like a KTM is almost like a 2 lakhs rupees, right? A Royal Enfield is around 1.5 to 2 lakhs rupees, and there is a 60,000, 70,000 bikes also there. Which is a better one for you? So like I feel which one is more comfortable, well known. I can easily write, so no problem. I don't need to think. So where is the gear? Where is the brake? Where is the kind of stuff? That is a better one. Okay, so that's what I'm trying to say. Point is, tell an answer how much you can able to tell in an easy way and better way, instead of murmuring more. Like you are to tell something more, or you want to tell, you are attempting something which is new lines. It just will give you more murmuring at the time. So better practice what you want to speak. Then you can able to give an answer. Okay, got the point, guys? Okay. So as I said yesterday, we're going to discuss about a networking devices. There's a lot of networking devices are there, so we can able to. Why it is? It is very normal color. Black is better. Various type of networking devices are a networking devices. That is enough. Okay, repeaters, hubs, bridges, switches, routers. These are important networking devices. Other than that one, also I'm giving some more devices. So, for example, modem. Modem is one of the important device. Okay, firewalls. In our system, we have a default firewall is also there, right? So, in our system, we have a default firewalls also there. Okay, so in our system we have a default software firewall is there, but in organizations there is hundreds of computers are there. So what they will do, they will put a one direct firewall, so between the outside network to inside network. So the firewall filters the traffic from inside to outside communication, as well as outside to inside communication. Okay, so that's like a firewall. Modem, firewalls. There's so many CSU, DSU units are there. Okay, access points are there. Also, wireless access point. VPN, proxy, proxy VPN are not exactly a devices, but we can add it. So what is VPN, what is proxy kind of stuff. Also better to know additionally kind of stuff. So that's why I'm adding the VPN and also proxy here. So generally routers, switches, so like wireless access point means Wi-Fi routers, modems. In a home we are using Wi-Fi. Wi-Fi routers also we are using, right? So what is we will discuss little about it. Okay, so description may not be there with me, but so we will discuss one by one. Hubs and repeaters are both are same. So this is a little information about a hub and how it is look like. Also, we'll try to put it. So what is a hub? It is a non-intelligent device. It means simply it's a board we can able to connect our computers to it. Okay, so you can see like a so network hub will take time. Okay. So I will take from here. This is this is a hub, and it is a kind of broadcasting device type. It is also doing some animations. Okay, look at it is if the first PC want to send a message to one of the PC. So what happened? It is distributing to everyone. Means it is broadcasting to everyone because it's a non-intelligent. It don't know what it is. Okay, it is also a hub. Hub and search are almost look like a same only. Okay, so if you see, observe there is a connection points are there. This is a RJ45 LAN connecting points are there. It is used for a LAN communication purpose only. Small networks suitable for a small networks. Why it is suitable for a small networks? Why it is showing like this? Because of it is a broadcast points. Okay, it's a broadcasting type. So what happens if you connect 10 computers, 20 computers, a lot of collisions will occur. It slow down your network speed. Okay, it slows down your network speed. So that's we are using for a 4 system, 5 system, no problem. Depends upon a single hub. Okay, so basic computation, not heavy data transmission. We don't use it. Small networks is okay. Internet distribution for 4 computers, okay, no problem. 5 computers, no problem. Not for 20, 30, 40, 100 computers. No, we don't use it. Okay, so use it for a LAN communication. It's a small computer. It is a layer 1 device. What is a layer 1 device? As per the OSI layer, okay, OSI, as per OSI, it is a layer 1 device. The meaning is physical layer. Layer 1 means it is a physical layer. Okay, so it know how to transmit the data, but it don't know exactly like what is a MAC address, IP address, that kind of stuff. You don't understand anything. You connect a PC. So I will explain with the paintbrush. Why my system got a very slow. Better to close few other things. So look at here. This is my hub, and I have a computers like this. Okay, everything is connected to hub. The way it is connecting, we call it as a star topology. Anyway, I'm taking, for example, like this. This is PCA, B, C, and D. Now I send a packet. So I want to send a packet A to B. So what happens? The packets go to hub. Hub receive the packet and distribute it to B and send to C and send to D also. Okay. So A send a packet to hub. Hub send a packet to B, C, and D. Now what happens here? So A send a packet, right? So B received it. Packet is for a B purpose only, right? So B received it and verify it's for me or not. Yes. Then it accepts the packet. Okay. It accepts the packet. C also received same packet, but it's not for C. It drops the packet. It drops the packet. D also dropped the packet. So C finally having its own packet. What is a disadvantage of this one is unnecessary are sending to everyone security problem. Okay, there is a security issue because you are sending not only to the exact destination, also it is going to others. So obviously security issues are there. Second one is more traffic will be generated here. So if you go through once again, for example, B want to send a packet to C. So B send a packet to hub and it is sent to A and C and a D. Okay. Now what will happen? Look at here. So what will happen? So A is not a destination, so it will drop the packet. Okay. B sending a packet. So obviously, no, C received a packet. Sorry. C received a packet. It take the packet because C is the destination here. D also received the same packet. It dropped the packet. Like A to B, B to C, C to A to D, D to B, like they are communicating each other. So every time it is keep sending to everyone. Okay, it is keep sending to everyone. So what happened? More traffic will be increases. There is a possibility of collisions occurs at a hub. So if collisions occurs, data loss occurs. Again, if data is lost, you have to send packets again and again. Okay, so that is the total story. Okay, so this is a broadcast communication. Like this. Number of what is this collision? Number of collisions occurs because it's a broadcast domain. It is also a collision domain occurs. Okay. Packet data loss. Okay, so that is another point. So we are using for a okay. So that's why we are using it for a small number of. Okay. So next one is a repeater. Okay. So what is this repeater? Repeater is nothing but a hub only. Repeater is nothing but a hub only. Okay. There is a repeater device is there. Hub and repeaters are used for same thing only. So what is that? So I will explain here. Look at here. Our cable. Repeater is a device, but okay, repeater repeat the signal. So signal. So here it is a mistake, right? Signal and sent to long distance. Okay. So this is a repeater. So what is this? You have a cable. It support only 100 meters. Now you have to send us. You have to connect the remote device which is more than 100 meters. So what I put, I'll put a repeater here or a hub here. So at almost like I reach 80 meters or 90 meters. At almost 80 meters, the signal will be decayed, right? So at 80 meters, I put a hub and I make another connection from here. Okay, up to here it is one connection. From here, it is again some connection. Now almost like another 80 to 100 meters. Easily, I can, if I have a device like this, I can easily connect it. So it just repeat the signal, means it receive the signal and send the signal. Okay, it don't take anything. It is just take it and give it. So automatically there is a power supply to this box. So to hub or a repeater, so signal will be forward to longer distance. Okay, so that is this one. Not, it won't boost the signal. Repeater don't boost the signal. Okay, next one is switch. Okay, switch. So about a switch, like again, what is switch and what are the facilities of switches and all. So we can able to go through once. But thing is, currently we'll see. So what is this? It is a intelligent device. It is a intelligent device. Intelligent device means it understand MAC address. and creates a MAC address table. Okay, and it works in a full duplex mode. Less broadcast, more unicast. Less broadcast, more unicast. Okay, it understands address learning and forwarding. So important is how it is look like. It's look like a ball. Okay, it is look like a hub only. But thing is, it's look a little bit. Okay, it is 8 port hubs are there. Okay. Why it is? Why it is? It has become a psycho. Okay. Okay, it is. It's look like this, and here we have to add some more points in it. So what are the other points you have to learn? Okay, use for LAN communication only. It is also used for LAN communication. Okay, which is used for LAN communication first of all. Okay, for a used for a small and large networks also. Okay, it is used for a small networks as well as a large networks. Okay, large number of devices can connect. Okay, large number of devices means multiple number of computers you can able to connect. That is the other point. Okay, so as for if you look at a hub, okay, number of collisions are limited, less packet data loss. So this is about a switch, not enough. So what is the difference between this hub and switch? Also, it's a big story. Okay, I will explain. Just try to understand. Look at it. This is a switch. Each switch having a port are there. Some are having 8 ports. Some are having a 16 ports. Some are 24 ports. Some are 32 ports, 48 ports, 72 ports. Switches also there. Okay. For example, this is a port number 1, port number 2, port number 3, 4, 5, 6, 7, 8. So totally 8 port switch it is. Okay. Now I have a computers. like this. So first one is connected to the first port. So this is connected to fifth port. This is connected to 6. This is connected to 7, 3. Okay. Guys, every PC having a MAC address. For example, this is PC A, B, C, D, E, F. So this MAC address is, for example, just for example, because MAC address is 12 hexa numbers. I don't want to write 12 hexa numbers. For example, I am writing like this. Okay, this is my MAC address. Anything, you can take anything for our understanding. It is not compulsory like a 1F, 12, 13, one kind of stuff. Anything you can take it. It's look like a something. Okay, just for our understanding. Okay, now here it is. First of all, A is send a message to B. A is sending a message to B. Okay, when it is communicating A to B communication, it is happens like this. A send a packet to B. So right. So A send a packet to directly your switch. Switch don't know where is B located. Like a your hub, it broadcasts to everyone. It broadcasts to it. It broadcasts to this. It broadcasts to here. Broadcast to D. Broadcast to F. Okay. Now what happened? B accept the packet and others drop the packet. Okay, others drop the packet because it is not belongs to them, right? This is one transaction. This is one transaction. So in a switch, what will happen? In a switch, what will happen? So it is prepare a MAC address table, also called as MAC table. It is also called as MAC table. MAT, MAC address table. Short form is MAC table or a MAC address table, MAT. So here it is. How it will be created like this. Okay. First of all, either MAC address or port number. So I'm taking first port number. Sorry, we got a column. And this is called a MAC address. Here it is starts. Port number is 1. And MAC address, because when you are sending a packet, you send along with your IP address and a MAC address. So it will immediately understand this port A, port number 1. This one number is connected to this PC and its MAC address is like this. Now part is completed. Okay. Next. Now, for example, C is sending a packet to E. C is sending a packet to E. C to E communication. Again, C don't know MAC address of E. It know the IP address. So it send a packet to switch. Switch don't know where is E because you don't understand IP addresses. Then it is forward to everyone. So it is broadcast. But what it will do, E accept the packet, remaining is drop the packet. Remaining people are drop the packet anyway. So just only one or two examples I will tell. It's a port number 3 is connected to this PC. So it's a MAC address is like this. Similarly, B is sending a packet, means replying to A. B is sending packet to A. B to A communication. Okay. Now what happened? B packet is forward to the switch, right? So then it is happens like this. B is connected to 2 and its a MAC address is 1B. Like this, when systems are communicating each other, so it will prepare the MAC address. The 6th port number is connected to E. So 7th port number is connected to 2. So I'll keep it all these things in black color. Okay. So this is MAC address table is prepared. Now new example I will take it. Now E is want to send a packet to A. Okay. Now E send a packet to A. Packet went to the search. Packet went to the search. What is the destination? E. What is A's MAC address? 1A. A's MAC address is 1A. So switch check that where is 1A is located here and where it is connected, port number 1. So packet forward to A directly through this port number. Through this port number. Okay. So this is become unicast. Initially it is a broadcast. Now it is unicast. This is the function of a switch. Help with the what is the, with the help of MAC address. Of course, there is some more things about a switch is there. For example, cut through switch, store and forward switches also there. But I'm not talking, like if you want, I will add those things also. Like this, different type of switches. If you have any time, then you can go through once that one also. Okay. So what is a switch, guys? Switch is similar to look like a hub. Okay. It is a LAN communication device. Use it for a small and as well as a large networks also. So large number of devices we can able to connect it. Number of collisions are very less and less packet data loss. Okay, and I given one explanation it is. So this explanation. I'll keep it here. Okay, so if you want, you can cut this one. If you understand, it is good. If you don't understand, it's okay, no problem. It's not a big deal. Okay. Yeah, some people will worry about not understand. But if you don't understand, ask me. I will tell again. Okay. This is how it is works. It is a very simplest point is MAC address table. Switch creates a MAC address table. So based on the MAC address table, we can easily communicate. It is a improves the security also. Okay. As for OSI, it's a layer 2 device. The layer 2 is data link layer. It's a data link layer. Better if I put it in a separate place. So it is become very small. This is very good. This is become very small. Okay, this is better option. Okay. Think it is still readable. Okay, so this is hub switches. Next point is routers. Next one we'll see the routers. Okay, here it is. The difference between bridge and switches are given, so that is also good. Okay, that's also good. So what is this bridge? Okay, um, what is the bridge? Bridge is not a device. So as per the list, we have a bridge is there, but actually bridge is not at all a device. Okay. The blue or black is okay. Some green colors is like this. We know how switches look like this hardware device, but bridge is a not a hardware device. Bridge is a something software device. So what is the software device? Guys, look at you have a computer or a certain system is there. For example, like this. This is a particular server is there. Okay, this is a server. It contains NICs. Okay, so for example, this is a NIC, and this is another NIC. Okay, so there is a bridge between it. It is a kind of virtual bridging kind of stuff. You create a bridge between it. Okay, and as well as this is also connecting to some different networks, some switches or some other systems. It is connecting. Okay, this is NIC1. This is NIC2. So this is, for example, a server and having a two NICs, and both are different networks are connected. So you can able to make communication between them. some different logical topology. Okay, you can see bridges are software based. Bridges have less port numbers, not more port numbers. This is literally a computer. Generally used to connect two different topologies or two different segments you want to connect, you can use it for a bridges. Or you want to make a communication between them, you can bridge between those NICs also. Okay. Earlier days we have a internal modems like a telephone wires are there, no? Landline telephone wires. So we have to connect our computer to the modem. The modem is connected to telephone line, and modem is either internal connection or external connection to the computer. So we have a LAN connection to the computer. So if we have a LAN connection, so what we do? So we are bridging the telephone wire connection to the connector, so RJ11 to this LAN connection. So that is distributed to our LAN. So means it's a big story, right? So again, I told our story. Look at here, it is, this is a machine, computer kind of stuff. Okay, we have a LAN connector is there, and as well as a either internal or external modem is also there. So we use this telephone cable from outside to this LAN connector. Sorry, this RJ45 modem. This is a modem connector. Here it is internal modem. This is our regular Ethernet NIC. Then we have a switch. So that is different network. This is different network. We connected like this. Through switch, we can connect it to multiple devices like this. Very good. Okay. So what happened? The server or this computer will bridge automatically. Like there is a bridging between these two things. So what happened? From outside, we are getting a internet, right? We are getting internet outside to inside. This internet is distributing to here. So these are all pieces will get internet like this. Okay, this is one point. And this bridging concept and bridging concept and is a very important understanding. We are connecting two or more NICs together to by using bridge connection. So virtual bridges are there. Okay, virtual bridges are there. Bridge concept is very good concept. So that is a bridge. Next. So wiring connection. So I'm not going with the wire connection and all. So where is router? Where is router? It is not much simple, guys. A router is given only 3 lines, but I will add more lines here. It's a 4 o'clock. How come I just started only? Okay, router is also a intelligent device. It understands logical addressing, fixed bandwidth. used for LAN and WAN communication purpose. LAN and WAN communication. As per OSI, it is a layer 3 device. The layer 3 device is a network layer. Okay. Normally, people don't want to mix things like a OSS separate, devices separate like that. Guys, if you're running like that, again, we cannot relate one to another one. So keep repetition so that's we can able to remember. Okay. So it is a router. Now it is Wi-Fi routers are showing. Okay. So I don't want that kind of router. It's a Wi-Fi routers. This is very good. A small representation of routers at all. Routers. The round symbol represents a router. The round symbol represent words. This router we are spelling, but it is root. What is the meaning of root? Root means path. Root meaning is path. It is a router. Router shows best path to reach destination. Routers use routing tables or routing tables. Routing tables created by manually called static routing. So we create our own routing table. So that is called as static routing. Again, routing tables created by automatically called by using routing protocols called dynamic routing. Okay. So what we are missing? Yes, dynamic routing protocols list. First one is IGP, Interior Gateway Routing Protocol. Next one is EGP, Exterior Gateway Routing Protocols. IGP protocols are RIP. Current version is version 2. EIGRP. If you check certain textbooks or internet, you can EIGRP. If you check in a certain textbooks, RIP, EIGRP, IGRP is there. IGRP, RIP version 1 is not working in a latest one. Means after 2600 model of router, it is not working. So current router software versions, it is not working. So simply. So these are the main three are there. RIP version 2, EIGRP, OSPF. open shortest path first. Exterior gateway routing protocols are BGP, border gateway protocol, IS, IS, intermediate system, intermediate system. There is a hyphen is there, guys. Be careful. Okay. I want to put it in a separate place because I like that one. It came easily away. So what is a route? Route means path. Router shows best path. To show the route path. Okay. You have to know how to reach destination. Okay. It uses routing tables. So how routing tables are created? Either manually or automatically. If you are created manually, it is called as static routing. Okay. If it is created automatically by using routing protocols, that is called a dynamic routing. So these are the dynamic routing protocols: IGP, EGP, interior gateway protocol, okay, exterior gateway protocol. So out of that one, RIP version 2, ASERP, YSPF, the most popular routing protocols. EGP, okay, so gateway protocols, it is like a border gateways protocol and intermediate system. So this is a basic information about routing. So why I didn't select all these things? So like this. So a router is a layer 3 device used for LAN as well as a WAN communication. So mainly WAN communication. Okay. WAN protocols also will be used here. And how the real Cisco router, not this router. So yeah, right, like this. This is the how Cisco routers are look like. Or you can use very big router size is also there. So this is how they are connecting. Okay, you can take any pictures. So how it is connected. I'm taking this particular picture. Okay. So this is about your basic part of your router. Okay. Topology sir came up, but I given some information about other devices. What it is? Modem, firewalls, access point. Okay. Um, Other thing. Okay. So we'll see those if possible. Otherwise, we'll take a break. Yeah. So in the next part, yeah, tell me.
I got a phone. Jay, all ko.
Someone is talking in phone. Okay, some are already left. No problem. So guys, take a break. Be back in 15 minutes. So we'll see the what is modem, firewalls, access point, and routers, or directly I will jump to topologies, because topologies, OSI layers are more important than this one. You can find it. What is modem, and you can easily find it. Okay, so that's it. Take a break.